Hi, everybody. What I want to do in this segment is get started in chapter 11, which is concerned with oligopoly. Just to kind of recap and give us some context. We talked about the idea that market structures span an entire spectrum from perfectly competitive, which we talked about, to purely monopolistic, which we've also talked about. The good news is we understand competition and monopoly very clearly. The bad news is there are very few examples of either in the real world. Most markets fall somewhere in between. What we're going to do is to start with oligopoly. So that's in between monopoly and competition, but closer to the monopoly end. Remember, that's a small number of firms. The firms have some market power. Entry and exit isn't so easy. And the way this is typically characterized, the way that economists often think about oligopoly, is that it's a sort of a game. It's a game in which there's a small number of competitors. They're paying attention to one another, and so they react to one another. Unlike in competition, where firms don't pay any attention to each other because there's no point, or monopoly, there are no other firms. In oligopoly, the firms are very much concerned with what their competitors are doing and what the best response is to the way their competitors behave. And so we're not going to call it this quite yet, but what we're really going to be doing is our first steps into game theory. And I think you'll understand this more as game theory as we go forward, but for now we'll just think of it as monopoly, as a model of oligopolistic competition. And so because oligopoly is messier, not as cleanly understood as competition or monopoly, we have to also take into account the fact that oligopoly can come in a lot of different forms. And so as a result, there are a number of different models of oligopoly that economists have constructed over a long period of time. And what we're going to do, since there's no single model that captures everything we might be interested in, what we're going to do is to learn about several different models of oligopoly. Each of them has their strong points, each of them has faults, but there's no real single model of oligopoly that we can turn to as there is with competition or monopoly. So this is a little bit messier, also a little bit more interesting. All right, so get started. And where we're going to start is a model of duopoly. I'm sorry, a model of oligopoly that's called a Cournot duopoly. And so duopoly just means that there are two firms in the market. Okay. And our assumption is that if we can model the behavior of a market with two firms, then if it were 3 or 4 or 5 firms, it wouldn't be all that different. And as we've seen before, when we just have two characters to take account of, life is a little bit more manageable. So Cournot is a French economist, Augustin Cournot, who lived in the 19th century. And he's credited with coming up with this model of duopoly. And this is probably the most widely understood model of duopoly among economists. It's not widely believed. I don't think it's the model, but most economists, when they think about duopoly, will often turn to Cournot first. So what are the characteristics of Cournot duopoly? We're going to have two firms. The firms sell identical products, so the product is homogeneous. the firms compete using quantity, the level of output, as the thing over which they compete. And the firms make their quantity decisions simultaneously. And so, again, to use the jargon of game theory, this is a simultaneous quantity setting game. So how does it work? Well, here's what we'll say. Suppose there's an inverse market demand. Let's call it price is A minus BQ. The firms are going to split this market quantity between them. And that's really where all the action takes place, is figuring out how to split that quantity. And so we'll write this as A minus B times Q1 plus Q2. Firm 1 and firm 2 have separate outputs. Okay. And so we can say price then is A minus B Q1 minus B Q2. Just expanding that. So this is what the market demand looks like. The demand is split between the two firms, and each firm now has to make a decision of how much to produce. So let's think about firm 1's decision. Firm 1 thinks about its demand, right? So this is its level of output. And so for firm 1, what it does is simply accept firm 2's choice as a given and chooses its level of output in response. So for firm 1, we can write the demand as price is A minus BQ2. So I'm really just rearranging this equation, minus BQ1. So firm 1 simply accepts that Q2 is some amount, 100 units, times B, which is the slope of the demand curve, and A, the intercept. So this whole thing inside the parentheses, in effect, becomes the intercept for firm 1's demand curve. And so firm 1's demand curve is going to look like this. It's going to have an intercept, A minus BQ2, and this is the demand for firm 1. The slope of this is minus B. This is referred to, this sort of demand curve is sometimes referred to as a residual demand curve. Firm 2 makes its choice of how much to produce. That determines the location of firm 1's demand, and this shows what firm 1 can now produce to complete the market quantity. If firm 2 were to produce more, so this amount, Q2 goes up, then the entire intercept would go down. So let's say this. Let Q2 prime be greater than Q2. At Q2 prime, the intercept for firm 1's demand is lower. And so this is what firm 1's demand would look like. What's happened? Firm 2 has decided to produce more, and that leaves less of the market for firm 1. So firm 1's demand is lower. If firm 2 were to produce less, then the demand for firm's 1 products would increase. And so you can see what's happening here. Similarly, we can look at firm 2. Oops. And so for firm 2, the demand is, price is A minus BQ1 minus BQ2. And so for firm 2, they take into account firm 1's decision, simply accept it, and that determines the location of their demand curve. So this is A minus BQ1, and this is firm 2's demand curve. So if firm 2 produces more, firm 1's demand goes down. If firm 1 produces more, firm 2's demand curve goes down. And so the two play off against each other simultaneously, okay? And together, they end up splitting the entire market, okay? How does the market actually function? Each firm has a quantity that it produces. And what we'll say is that each firm reacts to the opposing firm's output choice. So the quantity that firm 1 produces, Q1, is going to be determined as a function of how much firm 2 produces. And the quantity that firm 2 produces is going to be a function of how much firm 1 produces. Okay? And so each firm, and the firms are acting simultaneously, but each firm is reacting to the other's decisions. These two functions are called reaction functions, and they describe how a firm reacts to its opponent's decisions. We can graph these, draw a picture of them, and I'm going to put Q2 up here, Q1 down here. And the way we usually think about these is that reaction function for firm 1 is going to look something like this. So this is Q1 as a function of Q2's level of output. And this is Q2 as a function of firm 2's level of output. Oops, sorry. As a function of firm 1's level of output. That's Q2 as a function of Q1. Okay. So how does this work? Well, suppose firm 1 decides to be here. Firm 2's reaction function says, well, when firm 2 produces that much, we should react by producing this much. And firm 1's reaction function says, well, if firm 2 is producing this amount, then we ought to produce the amount given by our reaction function. So let's call this Q1 prime. Firm 2 says, well, when you produce that quantity, our best response is to produce Q2 prime. And so these reaction functions show the profit maximizing response to what the opponent does. So we started here, And you can see that there's a path we're tracing out. When firm 2 produces this quantity, firm 1's reaction function says, well, our best response is to produce this amount. And firm 2 says, when you produce that amount, our best response to that is to produce this amount. And you can see what happens is that the two chase each other until they get to this point. Right here, when firm 1 produces Q1 star, firm 2's optimal response is to produce Q2 star. When firm 2 produces Q star, firm 1's optimal response is to produce Q1 star. And so this point, where the reaction functions intersect, is the equilibrium for this model. So this is our Cournot equilibrium. Okay, and schematically, that's what this model looks like. That's how it works. What we need to do is to learn how to work through it algebraically as well. And I think we'll start with a clean sheet to do that. So let's suppose we have a market, and the market demand is price equals 50 minus 2Q. That's the inverse market demand. And let's suppose marginal cost is $5 for both firms. What we want to do is to find the Cournot equilibrium for this market. So what we need to do is to think about the fact that we have separate firms. For firm 1, the market inverse demand is price is 50 minus 2Q2 minus 2Q1, right? So this is 50 minus 2Q1 plus Q2. And I've just taken this and rearranged it for firm 1. For firm 2, the demand is price is 50 minus 2Q1 minus 2Q2. Okay. Each firm is a profit maximizer. And so each firm needs to choose the profit maximizing level of output. Firm 1 does this by setting marginal revenue equal to marginal cost. Firm 1 has this demand curve. This Q2 is just taken as a number, some amount that firm 2 is going to produce. So this is just the intercept. And that means that marginal revenue we're going to find for this linear demand the same way we usually do. Keep the intercept the same and double the slope. Same for firm 2. Intercept remains the same, but we double the slope. So now what we're going to do is to set marginal revenue equal to marginal cost. And so we'll say 5 is equal to 50 minus 2Q2 minus 4Q1. What we're trying to do here is, now again, I've dropped the parentheses because the parentheses aren't really doing a lot of work. They're just kind of organizing this expression for us so that we can see that these things are not choices that firm 1 makes. They're just conditions that firm 1 accepts. I've dropped the parentheses because it's just going to be a little bit easier to work with this with the parentheses gone. What this firm is trying to do is to choose the optimal level of Q1. And so we've set marginal revenue equal to marginal cost, and now we need to select the value of Q1 that makes those things equal. So what are we going to get? If we solve for Q1, I'll bring this over here and the 5 back, we get 4Q1 equals 45 minus 2Q2. If we divide through by 4, we get Q1 equals 45 minus 2Q2, sorry, divided by 4. We can go through this similar process for firm 2. We set marginal revenue equal to marginal cost. And for firm 2, we want to solve for Q2. So that's going to be 4Q2 equals 45 minus 2Q1. Q2 equals 45 minus 2Q1 over 4. We get these two expressions. What are they? These are the reaction functions. So this gives us firm 1's level of output as a function of what firm 2 does. This is firm 2's level of output as a function of what firm 1 does. Okay. To find the Cournot equilibrium, we need to figure out where the reaction functions are equal to each other. Well, we can set one equal to the other, and the reaction functions we see are equal when Q1 equals Q2. Is that always the case? No. It's the case here because the firms have the same costs. So the problem is completely symmetric. What firm 1 is doing and what firm 2 are doing are exactly the same thing. And so they're going to come out in exactly the same place. If we had set this problem up where firm 1 has a marginal cost of 5 and firm 2 has a marginal cost of 20, then these would not be the same. We'd have to work a little bit harder to figure out where the reaction functions intersect. But in this case, we can see that Q1 equals Q2. So how do we solve this? Well, we substitute. We say if Q1 equals Q2, then Q1 is equal to 45 minus 2 Q1 over 4. So I've substituted Q1 in for Q2 here, and now we can solve for Q1. We get 4 Q1 equals 45 minus 2 Q1. So 6 Q1 equals 45. That means that Q1 is 7.5. And Q2 is also 7.5. So this is the Cournot equilibrium. That's the equilibrium quantity for each firm. What's the price? Well, the price is determined for the entire market. So the firms have a single price. There's always just a single price in a Cournot duopoly. The price in this case is going to be 50 minus 2 times Q1 minus 2 times Q2. So that's 50 minus 2 times 7.5 is 15, minus 2 times 7.5 is 15. That makes the price $20. And how much profit does each firm earn? Well, again, in this case, where the problem is completely symmetric, the two firms are going to end up with the same profit. They're producing the same quantity at the same prices. Let's figure out the profit for firm one. Firm one's total revenue is price times quantity, so 7.5 times 20 minus its total cost, 7.5 times 5. Since marginal cost is constant, marginal cost is the same as average cost. So that's going to be 150 minus, what is that? Uh-oh. 4 times 7.5 would be 15 times 230. So this is going to be 37.5. Sorry about that. And so that makes the total profit 112.50 for firm one. And that's also going to be the same for firm two. You can work through the other side for firm two and demonstrate to yourself that that in fact is the answer. Okay. So that's a Cournot duopoly. I'm going to stop there. In the next segment, we'll do a little comparison of Cournot duopoly with monopoly and competition to see what the welfare effects are.